Any question?
This is the nearest first step.
Gotcha.
Just.
It would round up, yeah.
It would have just.
Yeah, exactly. It's kind of like the most annoying rounding with carry. Yeah, exactly. I would say so, and depending on how far away that is, that's a potential outlier from there.
Okay, that, even if it's like, well, I think it's right there, but it would be right.
I'd say it's still roughly symmetrical in this case. If you had more data going off to the right, now you've got a right
If it
skew.
was just like,
If it's just one observation, now you've got a big outlier here. I would still say the main data is pretty symmetric. Well, welcome back, everyone. Looks like we can get started. Any questions at all to start us off today? Yeah, go ahead. Well, how constitutes a uniform histogram? Absolutely. So if your histogram has a shape that comes out like this, let's say we have data right here, and usually we are looking at possibly unimodal, maybe bimodal distributions. But if the next peak goes like this, just slightly shorter, I said next peak, next histogram rectangle, the next one going to the right, maybe slightly higher and slightly lower, something about like that. And now going off to the left, you have something coming up, going right around here, then that could be your data. If this is our data, you might say that's the main peak, but it's just barely higher than anything else. And it's just by random chance, it's a little bit higher. All of these are just jumping up and down by tiny, tiny amounts. And this is what would qualify us having a uniform distribution. Sorry, say again? Not in this case, no. For us to really have a main peak on these data, it should look a little bit more like, say, this, for example. Maybe the data looks a little bit more like this. Let me erase that. It's no longer going to look uniform at this stage. If it starts falling away, but in a regular kind of pattern, then your main peak would be located right here in that case. Does that make sense between the differences? Gotcha. In either case, they're both symmetric distributions. This one's highly symmetric. And if we go back to the last one, slowly with Control Z, almost there. Then this one's highly symmetric as well. So it doesn't have problems with it. It's just a pretty unusual to get these kinds of data. The one example that we brought to class was a pretty interesting one, I'd say. Other questions at the moment? Okay. Well, we're getting through chapter 3. There's still a couple big sections that we're going to be going through when we come back next week. But for the moment, this is what chapter 3 is really all about. We're collecting data, and the data happens to be numeric. We're not worried if it's continuous or discrete. And then if our data, let me bring that back. If our distribution is at least approximately symmetric, we'll measure the center with sample mean and variability with the sample standard deviation. And that's what we were sorting out in section 3.2. So today will be exciting. We're going to look at distributions that we wouldn't call approximately symmetric or roughly symmetric. These are the distributions that are clearly skewed. We can't use the sample mean to describe the center. We can't use a sample standard deviation to describe the variability. Instead, we're going to be using these two statistics here. We've been mentioning them, hinting at them, but finally we're going to actually calculate them. Before we do that, any questions at the moment? Yeah, go ahead. It is, you know what, I kind of forgot. I have 3 classes and then procedures changes on a class by class basis. So
you can have 1 8x10 piece of paper with no.
Thank you. Yeah, I put this down just as a reminder for me because I constantly forget. It's different in all my classes. Other questions at the moment? Okay, well, let's get started then, folks. Now in this section 3.3, let me clear this off. here's how these notes start off. Now, it's going to be a wall of text, a bunch of formulas just like before, but keep in mind, our goal in statistics is not to get bogged down by these formulas. We'll be calculating things through the calculator on anything that's for credit, whether it's WebAssign, a quiz, or an exam problem. That's how we're going to get these done. But the sad thing about that is that's not the best way to understand the formulas. And we do have to understand what they're trying to say. So I'm going to do example one similar to how we did our notes in section 3.2. We'll do these by hand, see how it goes to get a feel for sample median, interquartile range. Then we'll show the procedures of running through it with the calculator. Example one is just contextless data. But example two, or I guess this is example three, this will be more similar to a bona fide WebAssign problem that we'd have to get through. Let's give this a start. We mentioned that we want to measure the center of our data, and the sample median is what that's doing right here. So this is for the center. That's going to tell us where our typical values are, where the data is accumulating. And if we want to say how spread out is our data, we use the interquartile range, IQR. So this is for variability. So let's give this a try. First thing we want to calculate is our sample median to find out where our center is at. But to do that, there's actually a pretty decent amount of things you'd have to do if it's by hand. First thing you have to do is order your n observations from smallest to largest with any of your repeats included, so you have an ordered list. So my example one, I saved us the trouble. I would never do that to you on a real exam where you have to order things. I mean, you put this in the calculator anyways. But if it's by hand, it does have to be ordered. So here we have it, all ordered, lowest to greatest. Yeah, go ahead. Yeah, that's what the sample mean would be, exactly. The median would also be measuring the center, but it's more the 50th percentile. All the questions so far? Okay, well, let's give this a try. We have our data ordered, but let's actually do a little bit more. Let's label these. We can call this X1, X2, X3, X4, X5, X6, X7, X8, and finally X9. So we just named all of our observations, X value, like we did in section 3.2. Once you get to the X9, it also tells us the sample size N is 9. If you're dealing with the median or interquartile range, you want to know if that's even or odd. So this one's odd. And now this is what it does for us. To calculate the sample median, it's a function that comes into two different pieces depending on your situation. If you have an odd index, or excuse me, sample size N like we do, then the median is just a single middle value. If we had an even number of observations, suppose there was an X10, then we would have averaged those two middle values that we would have had in that case. So this problem is pretty nice for doing it by hand. There is one central value. Anyone see where it is? Yeah, go ahead. Exactly. So it'd be this right here. So that's our median. It's in the center because we have 4 observations to the left, 4 observations to the right. And now we're ready to say, well, part A, we want the lower quartile, the median, upper quartile, and interquartile range. We just found this object. We need to label what it is. I'll call it M for median equals 74. So we've done it, folks. That's one thing down. There's a couple things in here that is new, though. It's asking for the lower quartile. I said new, I think we have mentioned them before, but we'll talk about them again, an upper quartile. Here's what they're referring to, lower and upper quartile. But to actually calculate your quartiles, effectively all you're really doing is you're taking the median again, actually 2 more times. It says the lower quartile is the median of the lower half of the data set. Now what's the lower half? Well, there's a central value, and so we'll call this set, going to the left, our lower half. Then the upper half will be this set, going to the right. So in order to get our quartiles, we just have to find those median values. Now, this is going to go a little bit different, though. The lower half has 4 observations. That means if we're going to do the median, we have to observe we have an even number of observations. And so we have to average the two middle values in that data set. So we'll be averaging 70 and 72. Keep in mind, average is synonymous with mean. We're just taking the mean of those two values. It's pretty quick. Anyone see what the mean should be of those two? Close. Very, very close. It'd be 71 in this one, correct. It's not terrible to get the mean for the two observations. These two are going to be way worse. So let's first do it for both, just to show what it would look like in case it was really, really bad numbers. So if I want to get the lower quartile, then we identify the lower half of the data set, average the two middle values, and it would look like this in the calculator. Take 70 plus 72. I put the parentheses around them. They can see up here above 8 and 9. Then division by 2, since there's two observations. And that's our value of 71 that we're going to get for the upper quartile. Any questions about that so far? Okay, let's put the calculator away. And here's where we do have a little interesting issue. There's no harm in calling it lower quartile unless you're looking at things in the calculator. I would suggest to call it Q1. It's a really good idea because that's what it looks like in the calculator, and it's a very, very common symbol. Likewise, for upper quartile, let's call it Q3. So quartile 1 is going to be 71, where we average those two middle values. We also want to find quartile 3, where we would be averaging these two values. That's not terrible to do it in our head, but I think for these kind of numbers, good to be accurate. Let's just treat ourselves to a calculator. 97 plus 123. Division by 2, it's only the two central values, gives us this next value. 158.5 does not sound right. I made a mistake there for sure. Anyone see what the mistake is? Good call. This was a real mistake. That wasn't a quiz or a test on it. I really just dropped that parenthesis. And what it then did was take 97 plus 123 halves, not quite what we want. So let me try it again. Oh, and I already made a mistake. Let me try it again. 97 plus 123, then close the parentheses, division by 2. That looks a little bit more reasonable. 110, it being the median, it should be between those values. It can't exceed or any one of them. So we have our lower quartile is 110. Well, any questions so far, folks, with either of those two values? Okay, so we have the median. It describes the center for us, but we also want to use the interquartile range to describe the variability of the data set as well. But the good news is the interquartile range is defined in this way: upper quartile minus lower quartile, or in terms of Q1 and Q3, it's quartile 3 minus quartile 1. So we're subtracting two observations. Keep in mind when you do this, it always has to be a positive quantity. So if you've got negative, maybe you just switched Q1 and Q3. Take off that negative sign and you still have the right answer. So last thing to do here, we want an interquartile range. We'll call it IQR. It's going to be third quartile minus first quartile. Really, it's kind of algebra at this stage for this process. You go where it says Q3 from the formula, look up the value. It came in as 110, so we're making a substitution. Then go back, copy in the negative sign, and look up Q1. That's the upper quartile, 71. And so that's our value to take there. So 110 minus 71, that should give us something like 39. Let me know if my numbers go sideways, but looks like we have it, folks. That's calculating median, lower, upper quartile, and finally, the interquartile range. Well, any questions so far, folks, on getting these values? Okay, again, like we mentioned, really when we do these by hand the first time, we're just taking a look at the formulas and seeing what they say. But what we'll be doing for a lot of these kinds of problems, is just throwing it into the calculator and see what we get out. So let's do that as our next step. Any questions first? Okay, if you have your TI-84 calculator with you today, good time to pull it out. So first thing we do is just throw in all the data. And first thing I should do is try to move the page so I can see all the data. Hit your stat button to start out. And then enter right away. And then just a reminder to clear L1, up arrow so it's highlighted, hit clear, and then enter. So your screen should look like this right before we begin importing the data. So now let me punch these in carefully and let's see what we get. Just going to try to zoom to a reasonable spot. This is actually kind of hard. Try the side-by-side display. That's usually a little bit more reliable. Okay, I think I should have all the data in. Giving folks one moment to get caught up. Okay, now with all the data thrown into the calculator, next thing to do is, just like before, hit the stat key again. So there it is. Move to the right tab so that calc is highlighted using the arrow keys. And now at this stage, just jam the enter key a bunch of times and you're in business. So here's our one variable statistics. Now we want to just double check, did we even get these right? Now here's the weird thing about these kinds of calculators. The TI-84 is going to do this problem the same way we did. Excel might, but if you use other general purpose statistical software, it all just depends. Turns out there is multiple formulas for calculating the median. And so statistical software, they don't always return the same exact values. The only thing that every software is trying to do is get the median as the 50th percentile, quartile 1, quartile 3, as 25th and 75th percentile. But there's more than one way to do that, which is really weird. And also, another thing that's weird about this calculator is, keep in mind, you don't have to do these problems by hand. In fact, I encourage you not to. It gets really, really tedious, and you just wouldn't be able to get through the problems fast enough. So here, to find the statistics you want, go to the down arrow, and this is where you need to be, right on this screen. Let me take a screenshot right here. And finally, here's our results. So the value they call med is median. So this is M, as our book calls it. The Q1 is nice. It prints it exactly like we'd expect. And same with quartile 3. That's also giving us the minimum and the maximum all at the same time. So in a certain sense, they gave us 5 numbers here, min to max, and the quartiles, including the median. This is a great way to summarize any data set that's numeric. In fact, this has a name. This is called the 5-number summary. So even if you have lots of symmetric data, sometimes people calculate the 5-number summary because it is still kind of interest. It gives you a lot of information all in a snapshot. Well, we've got it, folks. That's calculating these kinds of values. And now I have a couple extra questions to go along with it, but yeah, question first.
How do you get for all the values?
Oh, in the calculator right here, the first thing you have to hit is the stat key right here on the TI-84. And I always seem to do something weird there. If you ever get something weird like this screen, I think it's because I hit stat key during the output. The way to get out of this window is go second and this button right here to quit. Okay, let me try again with that question. Okay, it's powered on. To import the data, hit the stat key, then just hit enter right on this screen. Then all you're doing is punching in all of these observations one after another. Does that make sense for that question there? Gotcha. Other questions at the moment? Yeah. Sorry, say again.
All the groups that we do, are they in website or Moodle?
Oh, everything is pretty much in Moodle.
Okay.
So if you go to the top of the Moodle website, then it's got a lot of other stuff here, of course. It's got office hours. These are blank lecture notes in Word. But you can find right over here every single class lecture that we've done to date. We're recording one right now. You can also find here, these were blank PDFs, but after we solve the problem, they turn into the filled in notes. So they're just posted right to Moodle, right where you first would have seen them. Other questions at the moment? Okay. Well, we've got the 5-number summary, and now there's a couple more review style type questions we want to get through now that we're still dealing with these data. It asks us, are these data skewed left, roughly symmetric, or skewed right? And we want to explain our answer as we go. There's more than one way to answer this kind of thing, but any volunteers for an inkling on which way it should be if it's not symmetric? I feel the same way. It's kind of tricky. I'm really not too sure. There's actually a hint though between Q1 and the median. The median is really close to one of the quartiles, which means a lot of data is concentrated more so on one end than the other end. But seeing is believing, so if we want to see skew, we should at least have a dot plot. So let's go and construct one right now. That will be the explain portion of the answer. So I'm going to take all of these data. I'll just duplicate them here for easy reference. But what we really want is a really fast dot plot. So let's see here. Our minimum is 68. The maximum is 193. So I guess we can go in steps of, how about 20 this time? We have a lot of tick marks otherwise. We can maybe start at 60, go up to 80, 100, 120, 140, 160, 180, and 200. So I started at 60 so we can contain the minimum on the scale. I stopped at 200 so we can also contain the maximum of 193. And you could have gone by, say, 10s, 5s would have been very tedious, but it's okay to kind of be a little bit more abrasive and just go by 20s. If you're doing more than 10 tick marks, you're probably working a little too hard. Now, next thing we'll do is the actual bona fide dot plot. So first one at 68. Right here is about 70 where the red dot is. So my first dot would go here. Then at 70, right about here. 72, well, that's pretty close on my scale. So I'm going to stack that one like so. 73, I could probably make 73 look believable there. So I'm just going to move it to the right. At 74, that should be stacked as well. So I'll put it up above. Now, finally, we're up to 81 as my voice starts to break. So we're about here. 97, just shy of 100 in this location. Now we're at 123. That's going a little bit faster. Then finally, 193, maybe about here. So there is all of our data from the dot plot. And now that we actually see the dot plot, which direction would you say this is skewed in, if it's skewed left or right? Yeah, go ahead. Oh yeah, it's going off to the right for these data. We have a strong right skew with these trailing observations. And probably a good number of them would be considered outliers as well. Definitely this one's a far outlier. And probably these two might be classified as outliers as well. That's where the main body of the data is. So they just asked us really fast about symmetry. We'll say here, it's not roughly symmetric. It is skewed to the right. And that right skew, really because of these observations we see trailing on that direction. All right, I'm going to delete the table, only there for a quick dot plot. So now we have skew to the right. We can return to these statistics above for just a moment. It's actually kind of tough to tell immediately, but once you see that the median is closer to 1 versus the other, it does give us a sense of skew. Let's put that down as a comment. It's something we will return to in section 3.4. That's a preview to this idea. So I'll put here on the first bullet point, if M is closer to quartile 1, which we write as Q1, than Q3, the data is right skewed. And vice versa. If it's closer to quartile 3 than it is to quartile 1, now we're skewing towards the left because the data is concentrating on the right and trails off towards the left. So let's put that down as our next bullet point. If M is closer to quartile 3, the upper quartile, than Q1, the data is left skewed. So that's our quick write-up on how the median and the quartiles are giving us a sense of skew. But honestly, if you have to determine skew left or right, graphics are probably the best thing to have. That's what we'll be doing in section 3.4 as well. Well, any questions, folks, with parts A or B so far? Okay, well, continuing on, it also asks us to calculate the sample mean, which is going to be related to the table down below there. The good news is we already threw everything into the calculator, so we already have the sample mean. Let's pull it out. You turn on the calculator. We don't have to import the data again, it's already there. So I'll just hit Stat, right tab to calculate, and enter a bunch of times. Oops, didn't mean to do it too many times. We're going to round this one to the nearest 10. So this will be 94.6. And that's our X bar value. But also, if we compare it to the median came in as 74. The sample mean is much, much larger. And that's further evidence we're expecting right skew on our data. Whenever the sample mean moves far away from the median in a certain direction, that's giving us a direction of skew. Well, this one just wanted us to calculate the sample mean, so there it is. But like I mentioned, this really goes along with the table we're going to see below. But any questions first so far, folks? Okay, so our next table, let's see if we can move it up just a touch, is again doing a little bit more comparisons. Here we're looking at what happens if we compare the sample mean to the median. And we also looked here briefly, we'll return to these ideas in orange, what happens when M is compared with a quartile, one or the other. So first let's focus on this, the sample mean compared to the median. Our data is roughly symmetric. Let's just put in some quick graphics just for a reminder. We would have a picture that goes about like this. That's pretty symmetric, actually. Let's make it, well, we can leave it like that. So for our roughly symmetric data, if we compared X bar against the median M, let me actually put a different color there. Comparing X bar to M and a situation where you're at least roughly symmetric would give us this. They're not going to be equal unless that's perfect symmetry you really had in your data, but the sample mean, it's going to be at least approximately close to the median. It'll be close enough so that the sample mean X bar is the preferred statistic to use. On this display, if the median is about right here, then what side would you say the sample mean X bar would be? To the left or to the right of that red dot? Let's say move the red dot, sorry. It's pretty tough, right? If it's really tough to say where X bar should be, then you're looking at rough symmetry. They should be about the same. But as I look at this, let's see. It looks like there's just a slight skewing towards the left-ish. So it probably jitters off slightly to the left, but not very much at all. But let's look at something that really is truly skewed. Let's do one that's skewed to the left. Our data would look about like this for left skew. Just throw in some outliers for good measure, not that we had to, but it's left skew, now some tremendous outliers. And in this case, if we compare X bar to the median, which one would you say is larger, the mean or the median? Yeah, go ahead. It would be, absolutely. If we were to place the median, we're looking at where a value here will cut the area of all those rectangles directly in half. I'm not going to try to place it perfectly, but I'd say it's probably about here. Then what happens is, if you're skewed to the left, the sample mean moves off to the left at the same time. It would probably end up somewhere way out here, or right about in that location. And the further you skew to the left, the further the sample mean X bar is also going to trail off to the left. This is the case where we absolutely wouldn't want to use X bar at all. It does a bad job measuring the center. And here's another problem. If we have issues with measuring the center, because X bar is just not doing the job, you will have problems measuring the variability using the standard deviation. And the reason being is the sample mean is part of the standard deviation computation. It emerges right here. So both statistics just fall flat on their face. And that's why if we have skewed data, we're using median M and interquartile range, IQR. And just to finish off this last table, here's something right skewed. So really skinny rectangles in the histogram for no apparent reason. But it might look about like this. We don't have to make it skewed terribly. But in this case, for X bar compared to M, I forgot to do one thing here. Sorry about that. In row 2, we said it's larger. I wrote it down here, but I should have put this in, a greater than symbol. Let me put it in yellow just to emphasize that. Likewise, in this situation, the median is going to be somewhere right around here, cutting the area in half. The sample mean X bar is probably pretty close, but not close enough for it to be a reliable statistic. In this case, the sample mean would exceed the median because it's pulled to the right, away from the center. So these are topics or ideas we've talked about before, but here is where we finally have a formal table relating those ideas. Any questions at all, folks, with getting through these concepts? Okay, well, let's try out one more problem and then we'll call it a night. Our next exercise for the day, on example 3, finally has context. This is the 2015 Urban Mobility Scorecard from Texas A&M Transportation Institute, excellent university. They included data on estimated cost in millions of dollars resulting from traffic congestion for different urban areas in 2017. So say, for example, if you look at Houston, they're saying, if you look at the urban areas in Houston, Texas, they lost $5 million in 2017 simply because people are in gridlocked traffic. Some places were much worse, like say New York, Los Angeles, those are huge cities. Some of them not as bad, but these are the 13 worst cases. It's not a representative sample at all. We're looking at the absolute worst situations for traffic congestion. So immediately we took all this data and it's been dumped into a histogram. The total cost of millions of dollars is now the horizontal scale. And the frequency is just saying how many cities emerge in each of these ranges. So say, for example, where the red dot is, there was 8 different cities in our top 15 list that had traffic congestion causing between $2 and $4 million altogether. Now what we're going to be doing with these data set is calculate and also interpret the values of the median and the interquartile range using the context. Let me highlight that portion. We're going to start seeing this more and more as we do problems that involve our statistics, because once we calculate a number, it's not good enough to say the median is 5 or 15. We also need to say, well, what does that mean to the original problem? We can't connect that thought, then our statistics are essentially meaningless. They only have value once we interpret them. When it says context of the study, it means this kind of stuff. You have to talk about traffic congestion costing millions of dollars. So we'll return to this context here. But really, the first thing we want to do, the fun part, is calculate those statistics. Oh dear, but I forget, that's part A right there, right? We should really answer part A first. We don't want to skip that question. That'd be a bad test testing strategy. Part A says a histogram of the data provided. Describe the shape of this distribution. So that's not too bad. As far as shapes go, there's our main peak right there. So it must be unimodal. Absolutely, it's not symmetric. Which direction would you all say the skew is for this? Sorry, say again? Exactly, this is skewed to the right. Yeah, go ahead.
If they had 2 points that were the exact same height, is that bimodal?
It would be bimodal, absolutely. It would look something even, say like this. It's not even all that high, but once it becomes apparent data is surely accumulating right there, that's enough for me to call it bimodal in that case. Other questions so far? Okay, well, at this stage, that's supposed to be a comma right there. It looks kind of funky. At this stage, we still have to say one extra thing because there are unusual observations here. For right skewed data, this is not unusual. We expect data to trail off. But these observations, they're kind of far removed this time. It's not just a 1-box separation, it's 2 rectangles separated. So this one could be borderline, but this one, once we take a look at our rule of thumb in 3.4, it's probably going to become classified as an actual outlier. I'll say here, there are, or let me actually say that, and there are outliers on the upper end. So that's the shape of our data. And this is the kind of data that you would absolutely want to use certain values for the center. We'd want to use the median. And we would want to use the interquartile range to describe the variability. And after we do that, we'll say what those represent using the study's context. Again, that's to me kind of the hardest part about this. Well, any questions so far, folks, about discussing the shape? Yeah. I sure did, and thanks for spotting that. I would lose a lot of points if this was a real exam question. Let me slow down and get to that part. Let me hide those below. We want to know which statistics describe center. Let's put that in blue, and variability in green. Thanks for spotting that. I would have definitely lost credit there. So we said the data was skewed. And really, that's going to be our main determination here. I think this is a confusing question, not just because I forgot to read the whole thing, but also they're not asking you to calculate anything at the moment. They're just asking you to name those statistics. So I'll say here, center, use M. You can write it out as median, or you can just use our common symbol M if you like. And then I'll write variability. Use IQR, which stands for interquartile range. So those are the statistics we're going to use. They didn't ask us to explain, but if they did, you just have to say, since the data is skewed. Really, the first part of the problem is kind of the explanation to go with it. So that's what we're about to use. If it was roughly symmetric, we would have used friendlier statistics. But any questions or comments so far, folks? Yeah, go ahead. I do have some review problems. The review problems are these right here, sample exam 1 problems and the Blink lecture notes as well. And once we get to the, let's see, it would be this week right here. This is a normal week for us. I don't have a review planned into the schedule itself, but on the last day of that week, I'm not opposed to it. So I'll mention that. Come to class with questions from either anything over here or anything else, and I'll be happy to do like an impromptu review before the exam. Yeah, go ahead.
On the syllabus, you have that we have no class next Thursday.
Yeah, I have a scheduled conflict that's coming up. So this would be like a review on a Wednesday is where it would fall in. Thanks for reminding me about that. I need to post that to Moodle. But other questions so far? Okay. Well, let's go over to finally the fun part. We're really getting to it. We're going to calculate the value of the median and the interquartile range. But that means for the moment, let's turn up to right here so we can import all that data. So one more set of data import. We're not going to do tons and tons of this kind of stuff, but here and there, we do have to do it. So first, stat key to go back to our list, hit enter where it says edit, up arrow, clear, and then enter. So that's kind of our main set of keystrokes we always do. If you do this long enough, it's just going to become automatic. It becomes muscle memory. Now, the tough part is getting them all in exactly right. Let's double check. They said 13 observations, so we'll make sure that's how many we get. So at 15, 13, 7, 5, and 5. This is where I make mistakes. 1, 2, 3, 4, 5 fours. 1, 2, 3, 4, 5. Okay, then finally 3 threes. 1, 2, 3. It feels like it's just designed to mess me up. But I think I have it because it says here I'm at 14, meaning I should stop. I only have 13 observations. So hopefully we have it all in right. Let me know if your values are slightly different. Next thing we'll punch in is our stat button right here. Right arrow to calculate and enter a bunch of times. So finally, this is not it. But if we want median and interquartile range, here's the next trick in the calculator. Just down arrow a bunch of times and you'll have what you're looking for. Now, I put these in the notes, these little screenshots, just as reference. It's not something you need to do in your quizzes. That'd be kind of annoying, right? You'd have to print these out or send them digitally. But it's more for, geez, what I do? It's more for if you go back to these notes, it's just trying to help you find the things you need in your calculator. We'll say M for median is this value right here. So we've got that in. Next, we need an interquartile range. So IQR. First, let's throw in the formula. It's Q3 minus Q1. Then we do some algebraic substitutions. Q3 is a value of 6. So this becomes 6 minus the Q1 value is a 3.5. So we get a 2.5 altogether on that data or on that interquartile range. So with that out of the way, now we have to make an interpretation of what do these values even mean? We're trying to interpret the 4 here and the 2.5. Plus, we also have to use the context of the data as well. So let's give this a try. One thing that's always helpful with these is reminding ourselves, what does the medium M really represent in the first place? And it is the 50th percentile. So here's what we can say about the median. We can say that about 50% of these cities, let me see, did they say cities? Urban areas is probably the better way to say it. These urban areas have a congestion cost exceeding $4 million. So that's our first interpretation there. Let me move that down. And that's not something you would have to say about the median. You could say this differently. You could say half the urban areas have congestion costs due to traffic below $4 million, and that would have been just as fine. So that takes care of that value there. Oh, didn't mean to scribble, it's going for your eraser. Next, we want to interpret interquartile range as well. For me, this is the tricky one. And to see a good way to interpret it, let's copy down this histogram as a quick reference. When we calculated the interquartile range, we first used a value of 6. So right here, that was the upper quartile, Q3. Then we used the value of the 3.5. That was our lower quartile, Q1. So it'd be about here. And there's this range that I'm highlighting in this way. We can also go up through the histogram. In the histogram, this region I'm shading is about 50% of the total area in the histogram. And when we go from Q1 to quartile 3, what we said before is we're capturing the central 50% of all the data in our data set. So rephrasing that and interpreting it in our context. So interquartile range using the context, we might say something like this. Half of all these urban areas have let me consider this sentence one moment. It's not feeling grammatical. I want to put in front of half the central. The central half of all these urban areas have a congestion cost that ranges in $2.5 million. So what we're saying here is the central half, that's going to be going this way. And when we say ranges, all the interquartile range gives you is a distance, a range. This is the length of the central half of all of our urban areas. So it's about $2.5 million is how far they range in the central half. So that's our interpretation on these data here. Any questions at all, folks, on getting through this problem? Okay, well, when we come back on next class on Monday, what our goal is going to be next is we're going to take these data, the 5-number summary, and we're going to turn it into a brand new display. It's going to be called the box plot. And in that box plot, we're going to use this information that we see here in orange and just kind of build off what we're saying here, but using additional graphics all at the same time. So this is tough. We're just looking at statistics, but we'll have extra displays to go along with it. Well, any questions, folks, before we call it a night? Yeah, go ahead.
I just want to this lesson is the last lesson is going to be.
Exactly, yes. If you go to the Moodle website, our first exam is going to cover only those sections. Other questions so far? Okay, well, have a great night, folks. I'll see you all on Monday. If you start studying early, don't hesitate to email me over the weekend. I'll be happy to help out with your questions.